We have developed a formula for calculating a confidence interval for a population mean from a sample when we do not have the population standard deviation and we have a small sample size. This formula naturally comes from the formula for cases when we had a sample size greater than 30. For that case, we used the normal distribution. But for sample sizes less than 30, we need the student's t-distribution. Here is an example of what we can do with our new formula. From a sample of 10 industrial stocks, randomly selected from those listed on the Dow Jones, the average earnings per share, or EPS, was found to be $1.85, with a standard deviation of 0.395, or about 39 cents. Calculate the 99% confidence interval for the average earnings per share of all industrials listed on the Dow Jones average. The appropriate formula for this is our confidence interval, where x bar is plus or minus t sub nu alpha over 2 times s over the square root of n. Typically, we would have z in here, but because the sample size is less than 30, then we use the t-distribution. Okay? We can visualize the process by including the confidence interval, and we draw the appropriate distribution. So up here, we have the random variable x, which happens to be the earnings per share. Okay? This is the sampling distribution. So we have something like this. These are actually x bars. And what we have now is the particular x bar that we found from our sample. Okay? This value here is equal to $1.85, where s, the standard deviation we found from our sample, is equal to about 39 cents. Okay? Now, what we want to do is find the confidence interval around this value. So down below here, we have the normal distribution, except we've changed it to the t-distribution. Normally, this would be my z value, but in this case, it's going to be a t value. Okay? What we wanted to have was a confidence interval of 0.99. So I have up here 0.99. And I drop this down to here. And this is going to be 0.99. So that's what I'm looking for. What I'm actually after, when we put it on a graph like this, is I want to know that number and that number. I want to know the range of values within which, with 99% confidence, the true population mean can be found. Okay? So I have to have my t value down here. This is 0, of course, and my minus t value over here. So I can put it into my formula to get my range. Okay? Okay? To find the appropriate t requires two pieces of information. The level of confidence, in this case, is 0.99, okay? And the degrees of freedom. The degrees of freedom is equal to n minus 1. In this case here, our degrees of freedom, which Greek letter nu, often written df, degrees of freedom, is n minus 1. So in this case here, we have 9 degrees of freedom. Okay? We divide our confidence level by half. So I've got 0, 1 here. This is going to be alpha over 2, which is going to be 0, 0, 5. And this is going to be 0, 0, 5 over here. This is equal to alpha over 2. A confidence interval is two-sided, meaning you have probabilities on both sides. Okay? Now, we need to look that up, and when we do that, and we find it in the t-table, the way you do that is you go to the 005 column, and you go down to 9 degrees of freedom, and that's the t-value that we're going to place right here. In this case here, it's 3.2498, carried out to 4 digits for reasons I can't fathom. Okay? We take this number here, we put it in this formula. When we do that, we end up with a confidence interval of 1.44 on this end and 2.26 on this end. We state the formal conclusion as, with 99% confidence level, the earnings per share of all industries listed on the Dow Jones average is between $1.44 and $2.26. From a small sample, we are able to, with very high confidence, say what the average earnings per share of all stocks must be, plus or minus some number. But perhaps the most important feature of this tool is the ability to say the level of confidence we have in our estimates. After all, people are always giving estimates of this and of that. But when pressed, how confident are you in what you're saying? Then we see nothing but hesitation. Not required with us here.